This is Bob, and he will talk about an Arduino guitar. It is his project, and it's about a guitar that has no other controls but the strings, and I think it's a quite interesting project.
Okay, thank you. Thank you. Can everyone hear me? All right, so I'm going to talk about really the project itself, but also everything that came before the project, because I didn't know much about any of this stuff when I started playing with it. So I'm going to tell you a little bit about myself and how this whole thing happened. I'm not going to, there's a lot of things I might mention that you might not know about, but you can use Google, right? Everyone can use Google. All right, so there's two things you might want to know about me. There are two things really that characterize me. I have a lot of dreams. I spend a lot of time just sitting around dreaming. And I used to have very little money. All my life, practically no money. So with dreams and no money, you learn to scrounge. You learn to scrounge, and when you find something, you learn to fix it. And when you fixed it, you don't want it to break anymore. So you sort of become attached to things you got. That's me. And then you develop the ability to fix anything, which I think I have today, practically anything if I really want. But on the other hand, once I've fixed it, I get attached to it and I don't want it to break, so I get sort of this fear of losing it. So, poverty, dreams, and stuff, it becomes a sort of a mixed blessing where you have stuff and then you're afraid to lose it. The song says, when you got nothing to lose. But it's not really true. It's when you get nothing, you can't afford to lose anything. That's really how I've lived most of my life. And there's another aspect that I'm very tenacious, so I have this sort of never give up attitude. That's also a mixed blessing in a lot of ways. And one last thing about me, I usually like stuff that nobody else likes. I mean, I'm the only one who buys the one little thing in the shop that's been there on the shelf for 100 years and nobody wants it because they don't know what it's for or because they just don't like it. So, this whole project started. Does this work? I guess not. How do you change the slides? Ah, there we go. Electric guitar. So this whole project started, as a kid, I was a hippie. I'm still a hippie, lived in the 60s and all that. Played electric guitar, wanted to play electric guitar, couldn't play electric guitar, couldn't afford electric guitar, get a lot of junk electric guitars, have to fix them, don't know how to fix them. Anyways, I had this idea about electric guitars. And so first, what is an electric guitar really? It's got these things in the middle here. This is one of my guitars. It's a guitar that probably no one's ever seen before. There's only two of them in Belgium. It's made in Canada. So you get this one has two, they call them pickups. That's where it captures the vibrations of the strings to turn it into an electrical signal. And then here you have a switch, which routes the signals from the pickups to the volume and tone controls, which are here. And this guitar just has one volume and one tone. And then it all goes out through the jack to the amplifier. It's pretty simple. I mean, it seems pretty simple, although it took me a long time to understand. So that's what a guitar is. Now here's what I know about electronics. That's it. You're laughing, but I didn't find it very funny. I had spent a lot of time, even that, it seems so simple, and it is simple, but it took me a long time to understand things like, a voltage divider. What is that? How does that work? I'm still not sure I really understand. Anyway, so that was the way it was for like 30 years of my life. I knew V equals IR, I had guitars, they never worked. Then I got a job, a real job, a serious job, and I had some money. And so I decided to learn to play the guitar at last. I'm an old man now, old hippie. So I got a serious guitar, and a serious guitar requires serious adjustment. Even though I can fix anything, things that break and things that are expensive, you don't want to just tweak with. So I brought it to needed adjustment. I brought it to a luthier, a guitar shop, luthier is a fancy word for guitar maker, and these guys adjusted the guitar, and I learned a lot from these guys about guitars and about technology, and I learned that basically everybody wants the same thing that Jimi Hendrix played. That's all there is. The whole music industry is based on Jimi Hendrix played left-handed Stratocaster. Okay, not everybody's left-handed, but everybody wants a Stratocaster, so that's it. That's the #1 selling guitar, and that's it. The technology hasn't changed. 1950s, they invented all this stuff, and it hasn't changed, and nobody wants it to change because everybody wants to be Jimi Hendrix. And the mechanical potentiometers and a capacitor and a little mechanical switch, that's it. That was from the 1950s, and it hasn't changed. And even on guitars in 5-figure prices, I'm saying, you know, a $20,000 or $30,000 guitar, it's still the same guts inside. Nothing special. Okay, maybe the pickups are a little bit more sophisticated. Maybe the wiring is really poorly put together, because there are $20,000 guitars where it looks like it was soldered by a child. And I've seen it. I wouldn't have believed it, because at one point I was thinking about buying one of those at a special price, but when I saw the guts of it, I was just like, forget it. Forget it. So, you know, the 60s, I love the 60s because of hippies and because of peace and love and all that kind of stuff. It was great, and for a long time I regretted it. But then came along internet and the 21st century, and I found that 21st century is not too bad either. And in fact, it's really cool, especially the long tail. Living on the long tail is a cool place to live. And now everybody here, we're all on the long tail, whether we know it or not. So talking to these guys and things, I started thinking, you know, why does the guitar have to be so old-fashioned? Why can't it be in the 21st century, you know? Why does it have to have these mechanical things? And, you know, there's all kinds of stuff. For example, on that of the guitar I showed you, it does some cool stuff. It's not just an ordinary guitar. It does some pretty cool stuff. So basically you have, you know, the two pickups, you can have either one or the other or both. So both in parallel, both in series. Series is already an advance. I mean, this is only something that became imagined later, much later. But this guitar has all of that, and those are very, very sophisticated pickups, which were only invented, I guess, 10, 12 years ago. They're very sophisticated. It's a very sophisticated guitar, but it offers both the neck, the bridge. So the neck is the top one, the bridge is the bottom one. So you can have the neck, you can have the bridge, you can have the neck and the bridge in series, and the neck and bridge in parallel. So that's already pretty sophisticated for a musician. That's already incomprehensible for most musicians. My guitar teacher, when I tell him that, he says, "What do you mean? What are you talking about?" I said, "Well, I was just saying, it's like jazz and rock." "Oh, I get it. I get it. I get it. I get it." So, but even that, so you have, so what does that mean? That means that little switch there has 4 positions, huh? There's one for each thing. And if you want to start turning things on, turning things off, everything you need a mechanical switch, and you want to have individual tone controls, individual volume controls, everything means more mechanical stuff. And pretty soon you have your guitar just covered with buttons, and nobody knows how it works. Even yourself, even though you built it yourself, you can't remember which button to push to get this sound or to that. It becomes just a mess. So I thought, my vision was, let's get rid of all this electromechanical crap and put a screen on it, or make it, have a circuit in there, and then have a screen where you can have it synthetic and you can do all kinds of stuff. So why not? Why can't that be? And okay, we've already seen that. So that was my vision, was to have some kind of circuit on an Android phone and Bluetooth, and in there, you know, some kind of thing. I don't know what, an Arduino it turned out to be. That was my idea, and seemed easy enough. Modern technology, you know, stuff V equals IR, that's good enough. And why didn't this already exist? Well, I had a lot of friends or friends of friends in the music industry, and they all came up with the same answers. There's 2 reasons. Why? First of all, it's just unbelievably complicated. You need a team of engineers, hundreds of years of development, and it's just really complicated. And this was from engineers in the music industry. This is not just from musicians. Huh? And then the other thing was just nobody wants it. It's just ridiculous. Everybody wants to have a knob and a switch. That's what musicians want. That's it. That's it. That's all there is. So just don't waste your time. And so that's, yeah, I didn't really waste a lot of my time, but I kept thinking about it. And since I didn't know anything about electronics, it was kind of a handicap. It was kind of, you know, what to do about all this and how to make progress. So this idea just banged around in my head for a while, and then nothing happened. Then I used to go to a lot of TED, I still do go to the TED conferences in Brussels. I live in Brussels, and we have the TEDx there. And you get a lot of inspirational guys talking, and women talking about stuff they've done. And I went to one of these and had a good time with that. And I was thinking, you know, is it really impossible to make this? Or is it just people that are scared of it? And it made me think about Marshall McLuhan. Does anybody know who Marshall McLuhan is? 1 person? That's it? 2? 3? 4? 5? Well, Marshall McLuhan was a great thinker. He thought about mass media in the late 50s, early 60s, and he predicted internet in 1962. He predicted the arrival of internet with with a great thing where he said, in this new age, humankind will move from individualism and fragmentation to a collective identity, the global village. So he invented the phrase, the global village. But he wasn't thinking about computers. He was thinking about the electrical network that ran throughout the world. And he thought that was going to bring the entire planet together, electricity and the net, the net, electrical net. He was a cool guy. And he also thought about a lot of cool things like why innovation is so hard. And he said this second part, which is really apropos to my project and probably to a lot of things people do here, is that whenever you look at something new, all your references are in the past. So you look at something new with just thinking, well, is it like this? Is it like that? So a Mac, it's like Windows, right? Macintosh is like Windows. Everything is referring to the immediate past, and so that makes it hard to understand something which is radically new, and it puts people off in general from things that are radically new. So I was thinking, all these people who told me that nobody wants this stuff and it's impossible to do, is that just fear and a misunderstanding, or is there more to it? But I had no way of knowing what that meant or what was going to happen. And so, I always think of this story, the Henry Ford story. He was interviewed. I don't think this actually happened, but he was interviewed and said, how did you know people would like your cars? Did you go and ask them before? Did you go, user survey? And he said, if I had asked people what they wanted, they would have said faster horses. And, so he wasn't interested in making faster horses. So all these things were going on in my mind, and then I went to last year's TEDx in Brussels, and Mitch Altman was speaking there. Is Mitch by any chance in the room? No? Well, he was there, and he gave a very inspiring speech about hackerspaces and all this kind of stuff. And so I immediately jumped on him because he's an electronics guy, and I said, here's my project. What do you think? He said, of course, it's so easy. Of course, you can do it. It's a great idea. Go and do it. That was enough. One guy, never seen before in my life, convinced me that I should do it. Fine. All these experts told me, forget it. And so, yeah, it's a shame he's not in the room, but he gets a slide. So that's, he hooked me. He said, contact the hackerspace community. I didn't even know there was one in Brussels. Brussels? Anyway, there's a huge hackerspace community in Belgium and in Brussels, and I was amazed about this. And so, that's the meta part of the project. Thank you. And now we can talk about the technology and stuff, which is maybe interesting, maybe not. So remember this. So that's a potentiometer, right? Most people know what it is. You got a thing you turn, and it moves the wiper, the W. It moves that up or down, and that means that one resistance gets bigger and one gets smaller, right? It's pretty simple. So, and remember, we're having an analog signal coming from the, so it's a sinusoid coming from the pickups. So, the question was, how could you make that controllable digitally somehow? I thought about putting servos on there, motors, all kinds of stupid things. It was really, I had a lot of stupid ideas. But I put this out on the Hackerspace mailing list, and people had all kinds of answers, but it all seemed to be like it wasn't criticism, but they didn't know what I wanted. And I felt like there was some kind of, did you ever see Cool Hand Luke? What we got here is failure to communicate. And then they whack him over the head. That great movie, Paul Newman's masterpiece. Anyway, it was a failure to communicate. And that was something I learned a lot in this project, is you ask questions and they make perfect sense to you, but nobody else can understand what you're talking about. You ask a question on a forum and say, "Now, I got this thing and this thing and this thing," people don't answer, or they ask it with crazy things, then you realize that they don't understand, and they didn't understand. So finally, though, after a lot of questions, being tenacious, remember tenacity, we got to an answer by Johannes Thalmann, who's a brilliant scientist. Is he not here either? Well, he's in the hardware space, and he said, well, why don't you do it with a LED LDR? I didn't know if that was a word or if that was acronyms. Okay, great. Now tell me more about what that is. So actually, a LED LDR is really a LED, a light, and a light-dependent resistor. So you have something that shines light, and then you have something which changes resistance when you shine light on it. Okay, and you put those two together, and so that makes a digitally controllable resistance, because you can shine light more or less. You can pulse it with PWM, and then so now you have a digitally controllable resistance. And if you put two of them together, like in that picture, you get something very similar to a potentiometer. And all you have to do is manage the current. And in the meantime, I've been playing with, I got getting started with Arduino. I saw Banzi on TED, and I got the book, and I bought an Arduino, and I could make the LEDs blink. And yeah, it was great. Everything was great. All the problems were solved. It seemed so simple. It's like, what's wrong with people? Why is it so easy? It's just so unbelievably easy. So I started doing it. But somebody on the mailing list said, he said, I quote this, "It will certainly work to some extent, and even if the result is too noisy or bad quality to be used in music, it will still be huge fun to make." And I thought to myself, what? Noisy? Where's noise coming from? How can V equals IR? I don't see, where's noise in that equation? I don't get it. But that was it's kind of stayed in the back of my mind as something, but who cares? Went on. By the way, LED LDRs are actually, in the industry, they're called Vactrals. There's a component which has the whole thing built in one, and they're made by different companies. The best company is Perkin-Elmer. If you buy them, just put my name in the end so I get my commission, okay? All right, so that was easy. So now I had the fundamental problem solved, and now I just had to learn how to do it. So I read Making Things Talk by Tom Igoe, who I later corresponded with, and found out that he didn't test all the code in his book. So here it is. So the idea was really you have a guitar, an Arduino in there, a bunch of Vactrals, and then you have some kind of a Bluetooth, and you have some kind of device, a computer or Android. I'd never seen an Android phone in my life at the time, but I figured that would do it, and it would be really easy. Yeah, and it was. So here's the really the geeky part, huh? This is the schematic. I only made it because the person revising my presentation here told me to make it more technical because it's a technical conference. All right, so here's the technical stuff. You wanted it, you got it. You want it, you got it. Okay, on the upper left there, you can barely see it, but you have so there's three. I put three pickups. This guitar has three pickups. And you see there's one sort of double pickup, which is exactly what it is. So the three pickups, they come in. So the top one goes in. You have the red wire. It goes to a Vactral, which is just an on and off Vactral. So it's got no variable resistance. You just shine all maximum light, and it lets maximum electricity through. It's not perfect. The Vactrals I use have about 80 ohm resistance when they're full on, but you can do a little better than that. I didn't buy the right Vactrals. I couldn't understand how to read data sheets. They're so complicated. Why don't they just say what I want? Anyways, so there you have it. So each of the pickups goes into a Vactral. Those top four are the switching Vactrals. So you have one per pickup, except for the last pickup, which is two pickups, actually two coils. So that means you have to be able to have both coils on, or in my case, I decided to have both coils in series, or only the top coil. That's a typical configuration for guitars. It's called splitting a double coil. So there's a Vactral which does the split. Then you have the orange raw, let's say raw input bus, which goes to the Vactrals, which pretend to be a potentiometer. Another one pretends to be the tone control, which is just half a potentiometer and a capacitor to ground. And then the last one was a trick I thought of to be able to have maximum volume, because the other ones were all being controlled by PWM, pulse width modulation. So I could never get the full light with that. So I just had another one where I could shunt them all out and get full volume. And then it goes to the jack out. And you see, one of the great things about Vactrals is this whole circuit is optically isolated. So this part is not in any electrical communication with that part. And the ground is provided by the amplifier. So it's completely separate from the Arduino ground. Something I had to learn the hard way. And then you have the resistances on the bottom there, which control the current to the LEDs. And something I don't understand is I ended up just empirically testing all different types of resistance to get the amount of light I needed, and I ended up with microscopic current to the Vactrals, which was not on the data sheets at all. It says I don't know how it works, but it does pretty well. And then you have the Bluetooth radio. I ended up using a SparkFun radio. The time is running out. I'm sorry. I'm going to have to just skip over all this stuff. And then I wrote, I bought this old guitar. It's an old 1980 RG-140 from Ibanez. And they didn't give me permission to use pictures in the show, but they can't prevent me from holding it here. So anyway, and I used a very inexpensive JY MCU Bluetooth radio module to connect to the thing. Cost €5. And I couldn't understand why it didn't work very well. I mean, €5, come on, it's a lot of money. But I ended up having a lot of problems with that, with noise actually. But let me tell you, before I talk about the problems, when I plugged it in the first time and I built the circuit and soldered it all with prototype board, it took hours, even days. I made some mistakes, had to unsolder. Put it in, plugged it in, turned it on, and it worked. And it all worked the first time. I felt like Dr. Frankenstein, you know, when the lightning hits the thing and the monster wakes up. That's exactly how I felt. It was just great. It was the high point of last year, I tell you. And so, I mean, that's all the good news. I'm not going to talk about the software development. That's kind of just software development. I wrote at first I wrote a GUI in PySide, Python plus Qt for my laptop. That worked really well. That worried me because I knew when the prototypes work that you're in trouble for the final version. And then I thought about Bluetooth. I read in Tom Igo's book about how to do it. I copied his code, didn't work. I wrote to him. He said, yeah, well, I never tested it, sorry. Okay. And then I managed to get it to work. And then I had to port it to Android. And I found out that Python on Android is sort of no, especially PySide on Android. It's even like no. So forget about that. And I thought, okay, well, I'm going to learn the Java framework. And a lifetime of learning, forget it. And then I found that processing could be byte compiled for Android. And so you just encapsulate all the Android Java framework in processing. And that was easily done, except that the Bluetooth library for processing, KTI library, had a good amount of bugs in it. I wrote to those guys, and they had ended up. So, for example, there's a function called connected. It always returns false. Are you connected? No. But the signals are coming back and forth. No, we're not connected. That's a good one. But so you couldn't use that. Anyways, so that was the next slide, and we've already seen it. So you have, on the one hand, you have processing, Android, and Bluetooth. On the other side, you have Vactrols, Arduino, C++, and then a Bluetooth module. Maybe I'll skip. I had a huge amount of problem with noise, but it's worth. So I showed this around. I showed this around to musicians now. All these people who told me it was a terrible idea, and they all thought, wow, it's great. All you got to do is this and this and this, and it'll be great. And the first thing they said was get rid of the noise, because there was a terrible whistling noise, and they were right. It was awful. I couldn't understand where it came from. I couldn't understand how anything could get through the optical barrier. It didn't make sense. Okay, but they also said maybe make a pedal for it, and maybe we should show how it actually works. That would be nice, I guess. Huh? I can show you how it works. Turn it on. Now you hear the noise? That's the noise, but that goes away. Don't worry. Once we turn it on. Here's the screenshot from my Android tablet. There's a huge lag with the Android development thing. So this is the GUI that I used today, and you see you have the pickups which you can select, turn them on, turn them off. You can split this one, and then you have all these on the side. You have preset configurations, which I called configurations. And musicians said, "What do you mean?" I said, "Well, it's like things you always set up ahead of time, and you just click. Oh, you mean presets?" I said, yeah, that's what it is. Presets. So I learned you don't call configurations, you call them presets. You have to learn the language of the domain. That was something I learned how. And then, so I made a famous one, the woman tone. The woman tone is is it coming? Yeah. Eric Clapton had a famous sort of jazzy blues tone, which he called woman. And this offended many, many people. Like, why? Why do you call it woman? What's that? What's that? I said, it's Eric Clapton's woman tone. Why is that on a man button? Sorry. It's, and then there was the long search for the whistling noise. You don't hear it anymore, right? There's no whistling anymore. There's no whistling, but there was whistling, and it was and it was during communications. So when you sent it, when I typed something on the keyboard here on the voice, and then again you could hear the whistling through the amp. And it was really annoying, and it would last exactly 10 seconds after the end of communication. So this was really annoying and really painful. And so I had all these forum discussions, especially the best forum was the Android Electronics, General Electronics Forum. It was my thread was the top of the list for months. Literally, there was like, must have been 100 or 200 responses and people, and there was some guy, he must have spent all of his waking hours trying to figure it out. But he couldn't, no one could. I could, and and finally I had this idea that it seems to be coming from the Bluetooth. Why not contact the Bluetooth people, Bluetooth manufacturers? So I didn't know any. So I saw SparkFun had a Bluetooth module which costs upwards of 30 euros. It's a lot of money. So I wrote to them saying, if I buy this, is it going to help? And they said, how would we know? We're not Bluetooth. Call our, we use the roving networks RN42 chip. Why don't you contact their support? So, well, I'm not a client of, I'm not a customer for SparkFun. I'm even less a customer for roving networks. Never heard of them. But so I wrote to roving. I don't care. I'm afraid of nothing. I wrote to the president of Honda about my Honda's navigation system in Japan. He replied immediately and fixed it, by the way. So anyway, I wrote to roving networks and told them the story, the JYMCU. So the guy said, yeah, I've investigated the JYMCU. I've been looking at the specs, and it does like this, and like this, and like this, and it's got all these problems in it because it's not this and it's not that, but our chip is like this and like this, and it should be a lot better, but of course, who knows? So I bought their chip. I invested 30 euros after great hesitation. And I know, but this is the end of the story. And I plugged it in, and it was almost perfect. Almost, really close to perfect. Most of the noise was gone, but a little bit still. And I thought, electromagnetic interference. I finally learned that. I saw that somehow. I came across that EMI. I thought it was a record company, but no, it's electromagnetic interference. My girlfriend used to work. Anyway, someone I used to know worked with. Anyway, EMI, electromagnetic interference. That's the problem. So how do you figure out? How do you solve that problem? Who knows? It's just impossible to solve. So I contacted shielding companies, and they told me all this stuff, and I just couldn't understand. Way too complicated. But automation was the last part of what the musicians. You won't be able to see it, I don't think, because the response rate is not fast enough. But you can hear it. So I'm now. There's no effects pedal. I'm now creating a tremolo just by changing the volume rapidly, the volume and tone. So that was so automation. This can do unlimited forms of automation. You just have to write a few lines of a little text file, and it will automate. But that allowed me to automate the communications, and I could look more carefully at the problems. And by miracle, I discovered that I built a stethoscope. I called it. You just take a cable, a guitar cable. These are heavily shielded, but the tip is not shielded. And you turn the amp up full blast, you hold the cable, the tip of the cable near what you're looking for, where you're looking for a noise, and it acts like a stethoscope. So, I held the tip near the Arduino, nothing. Vactrils, nothing. The RN42 chip, nothing. Where was the noise? It was there's two serial wires between the Bluetooth and the Arduino. So serial wires have square waves going down, right? So pulses. I can imagine now the square waves going back and forth, and coming out of my amp. That was the problem. And so I put lots of shielding on those wires, and it all went away. And now we have something that works. And she's trying to chase me off the stage here. And so I can just show you, maybe if you want to see, that's a 3D view of the pedal that I've almost finished. This was an early view, so it doesn't have a lot, the guts of it. But so the next step is a pedal, because although professional musicians have sound people, and people who come on stage and tell them to get off, people like me don't have sound people, and it's not really practical when you're playing to tap on a touch screen. So, but a pedal, on the other hand, it's really practical, and it's really easy. Just take away all the Android problems, having just an Arduino in there, except that Arduinos don't have much RAM for programming, so I have to make a really sloppy code and compress it. But it works, and all these things work, and I'll be in the hardware hacking area later for anyone who wants any more details or wants to play with it and stuff. That's all.